So let's look at problem 20, where we have y equals x squared minus 6x and y equals negative x. Okay, let's read the problem. Find the area of the region bounded by the graphs of the given equations. X squared minus 6x and y equals negative x. Okay. Yes, when we want to find the intersection points, let's set them equal to each other first. That's a good idea. So this is x squared minus 5x equals 0. We're finding the points of intersection. Points of intersection. By setting them equal to each other because y and y are the same. So x squared minus 6x equals negative x. I add x to both sides. I factor out x. And there are two possibilities. When x is 0 and when x is 5. And now I have to find the y coordinates. How much is y when x is 0? It doesn't matter where you put it in. Excellent. 0, 0. And how much is y when x is 5? Negative 5. Anywhere you plug it in, you have to get the same number. It doesn't matter if you go back to the first or if you go back to the second. It must be equal. Because we set them equal to each other. And that's how we got the x. Good. So now let's graph them. One of them I can graph right away, which is this one. Remember, we know that this is y equals x, but this is y equals negative x. Now the other one, anyone remembers what type of function is it? Quadratic, very good. And the x-intercepts are y equals 0, I get x equals 0 and x equals 6. 1, 2, 3, 4, 5, 6. Okay? Does it have a maximum or a minimum? The leading coefficient is positive. Yes. Minimum, right. So where is the vertex? Excellent. It has to be right in the middle. If the x-intercepts are at 0 and 6, it must be here on x equals 3. It's a must. So when I plug in 3, what do I get? 9 minus 18. Negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's the graph. So this is y equals x squared minus 6x. Let's read the problem one more time. Find the area of the region bounded by the graphs of the given equations. Is there an area bounded by these two graphs?
It's in between, yeah, right there.
Do we have the points of intersection?
Yes.
One is,
0, 0.
and the other one is?
5, 5.
Exactly. We just determined them. Okay. So now, we will integrate. We're talking about an area, right? We will integrate between 0 and 5, right? 0 and 5. From the upper function, this is the area, minus the lower function to get this. So the area is the integral from 0 to 5, because that's where it is, between 0 and 5, from the upper function, which is negative x, and subtract the lower function, which is x squared plus 6x dx. So every time we find areas enclosed between two graphs, we always determine the area between the upper function minus the lower function. The integral from this minus the integral from this.
So say that had a maximum and it was on the top, that would be the upper
Still the
function.
top minus the bottom, no matter what.
Okay.
Top minus bottom. Very good. Okay, so remember that I subtracted. I subtracted x squared and I subtracted 6x because I have to distribute. Okay, perfect. So the integral now is the integral from 0 to 5 from negative x squared plus 5x dx, which we know is negative x cubed over 3 plus 5x squared over 2 from 0 to 5 as we did all the time. So negative x cubed over 3 prime is this, and 5x squared over 2 prime is that. And I have to use the limit of integration from 0 to 5. Luckily, I don't have to plug in 0. I only have to plug in 5. Negative 125 over 3 plus 125 over 2. Because I have 25 times 5. The least common denominator is 6. This needs a 2 and this needs a 3. But of course, I'm going to pull out 125. I'm not going to implicate that. So it's negative 2 plus 3. So this is 125 over 6. I have 125 outside, so I don't have to multiply at all. And then I have minus 2 plus 3, so which is 1. And this is the area between those two. Please choose anything else so we can practice finding areas. And I would like to apply this in word problems. Memorizing again is popping up. And I also want to find the average of a function. So if we have a function on the interval a comma b, the average f of x on the interval a comma b is 1 over b minus a, the integral from a to b from f of x dx. So if we have the temperature function and you say calculate the average rate, the average temperature between such and such, this is the way we calculate. But we have to have the function. So let's find an average and then we'll go back to other problems. Okay, so I'm looking at 57, outside temperature. Outside temperature. No more applications and no more new stuff. This is the end of chapter 4. We'll practice whatever you want to. 57 on 415. Suppose the temperature in degrees Celsius over a 10-hour period is given by, so T is between 0 and 10 hours. F of T equals negative T squared plus 5T plus 40. Part A, find the average temperature between 0 and 10. Average between 0 and 10. What do I do? How do I write this?
10 minus 0.
Right, so it's 1 over 10. The integral from?
0 to 10.
Good. From negative T squared plus 5T plus 40. And what else?
Yes.
Good. But dt.
On DC.
Yes. No integral without d something. Good. So then this is 1 over 10, and negative t cubed over 3 plus 5t squared over 2 plus 40t from 0 to 10. And luckily, we only plug in 10. 1 over 10, negative 1,000 divided by 3 plus 500 divided by 2 plus 400. This will be the average temperature between 0 and 10. So let's see what we get. 1 over 10, this will become 250. So negative 1,000 divided by 3 plus 650. 1 over 10 times 3. Negative 1,000 plus 1950. So this will be 1 over 10 times 950 over 3. Or 95 over 3. Or 3, 1, right? 0.2 degree. No, this is Celsius.
How did you get 1950? When you, after the 1,000 over 3 plus 650.
3 times 0 is 0. 3 times 5 is 5, and I carry 1. 3 times 6 is 18, plus 1 is 12.
Okay.
Adding fractions.
And since you did it, why do you have to divide them?
This is how we add fractions that don't have the same denominator. I have to change this fraction
Not that
from
part, I'm
650.
talking about the very bottom.
Right. I have to change this fraction, which is 650 over 1, into something else over 3, so I can add to that fraction. And that something else over 3 is 1950 over 3. So negative 1,000 over 3 plus 1950 over 3 would be this.
So 650 times 3 is yeah.
Okay, so part B. Find the minimum temperature. How do I find the minimum temperature? Let's write the function one more time. The interval is 0, 10. And in part C, they want the maximum temperature also. B and C together. Remember what we do for a closed interval. What do we have to determine first? When we talk about max min, always. We determine the, yes, first derivative, and we need, exactly. If a function does not have critical numbers, can it have max min? No. Very good. So f prime, negative 2t plus 5. We set it equal to 0. And we get t equals 5 halves. Is 5 halves between 0 and 10? Yes. Otherwise, I cannot put it in. So I will determine the function value here, and here, and here, and make a decision in a minute. And study the sign of the derivative. Ready? So let's put in the function in y equals. And that is negative x squared plus 5x and plus 40. So second in table, I need 0, I need 2.5, which is 5 halves, and I need 10. So I copy 40 degrees, I copy 46.25, and I copy negative 10. I put them in my table. So now let's study the sign of the derivative before you even look at these numbers. That's how we know whether we made a mistake or not. So plug in 0 and tell me the sign of this. Very good, excellent. Plug in 10 and give me the sign of this. Perfect. And now we have to see whether this works. from 40 to 46, the function is that supported by the sign of, from 46.25 to negative 10, what does the function do? Is that supported by this? So then, can anyone give us the max temperature and the min temperature?
The min would be 40. Or negative 10.
Good.
The max would be 46.25.
Because this is clearly the sequence of signs and positive, 0, negative for a max. Very good. So this brought us back to what we studied in previous chapters. What else? We still have 5 minutes, so let's choose something else. Let's choose one more function, if that's okay with you, to look at areas between. Let's look at 17. And we consider chapter 4 finished. And if you find anything that you would like to work on, please bring it to class. So y equals x plus 2. So page 413. And y equals x squared. Yes, it's a good idea to start by finding the points of intersection, meaning x squared equals x plus 2 or x squared minus x minus 2 equals 0. Can anyone give us the factored form of this?
X minus 1, x plus 1.
But it's minus 2, x plus 1, so x equals 2, x equals negative 1. And I also need the y coordinates. So 2 comma, negative 1 comma. So when I plug in 2,
Get 4.
I get 4 indeed. When I plug in negative 1, I get
1.
perfect. So let's graph. I know how to graph x squared. There is no problem with x squared, right? This must be x squared. But now I have to graph x plus 2. When x is 0, how much is y? Good. When y is 0, how much is x?
Negative 2.
Perfect. So this is the graph. This is the graph of y equals x plus 2. Is there area? Enclosed. Do we see the area enclosed? We already determined the points of intersection. Can anyone give us this point and this point? My graph cannot be perfect, of course, but I already determined algebraically what this point is.
1 negative 1. Negative 1, 1.
Perfect. And what is this point?
2, 4.
So then I'm integrating from?
X plus 2 minus x squared.
Very good. So the top, no, from the top minus the bottom, always. From the top function, that's why I wrote them here so we don't make a mistake. From the top function, I subtract the bottom function. Good, so it's x plus 2 minus x squared. Is that clear? Okay, now I need the limits of integration. From left to right. From what to what?
Negative 1 to 2.
Exactly. That's where the limits of integration are, right? Between negative 1 and 2. That's where they intersect. Excellent. So then this is x squared over 2 plus 2x minus x cubed over 3 from negative 1 to 2. Well done. I will plug in 2. 4 over 2 is 2 plus 4 minus 8 over 3. But minus, careful, open parentheses, 1/2 minus 2 plus 1/3. So I plug in negative 1, so it's 1/2. I plug in negative 1, so it's negative 2. I plug in negative 1 Negative 1 cubed is negative 1 with minus in front will be positive. So finally, I perform the operation. So this is 6 minus 8 over 3. And this is minus 1/2 plus 2 minus 1/3. So this is 8 minus 8/3. No, minus 9/3. Oh, that's nice. And minus 1/2. So 9/3 is 3. 8 minus 3 is 5. 5 minus 1/2 is 11/2. So this is the area